Hi everybody, this is Pre-Calculus, Chapter 1, Part 3. This part covers nth roots and fractional exponents. And we already went over this in Algebra 2. So this whole first chapter is mostly review stuff. Alright, so if n is a positive integer, an nth root, if a number x is a number which, when raised to the nth power, gives us x. So basically what they're saying, the nth root would be like x to the third. This is the third root. X to the fifth. This is the fifth. Right? So those are going to undo each other. Okay? So nth roots just mean what would undo. Like that's a square. Here is a square root. Those undo each other. Right? X to the n is the same thing as saying, to undo that, we're going to need the nth root of x. Okay? Nth just means it could be any number. Alright. Examples. 4 is the third root of 64. Because if we say 4 to the third, we're going to get 64. Or if we say 64 third rooted, we're going to get 4, because 4 times 4 times 4 is 64. Both 2 and negative 2 are the eighth roots of 256. So if we said 2 to the eighth, we would get 256. Or if we said, what is the eighth root of 256, we're going to get 2. 2 times 2 times 2 times 2, 8 times. But it would also be true if we said negative 2 to the eighth, right, is 256. Because those negatives would cancel each other out if we had 8 of them. So negative 2, 3, 4, 5, 6, 7, 8. Remember, 2 negatives cancel each other. Cancel, and it's all positive. Now it's 2 times 2 times 2, and we get 256. The positive root is always called the principal root, okay? So for the positive one, the positive 2 right there is going to be your principal root. All right, negative 1 is the fifth root of negative 1. All right, so that means negative 1 to the fifth, or the fifth root of negative 1 is going to equal negative 1, because negative 1 5 times, negative 1 times, negative 1 times, negative 1. 1, 2, 3, 4, 5. And when we cancel these negatives, we're going to be left with 1. So this is negative 1. Negative 1 is the 997th root of negative 1. So no matter how many times we exponentially multiply this, we're still going to have negative 1. So if we did negative 1 times negative 1, 9,997 times, we're still going to get negative 1. There's no real 12th root of negative 1. All right, because if we said this 12 times, right, we're going to cancel these negatives. And it all comes out as positive 1. So we can't root it back down to get negative 1. So there is no 12th root of negative 1 that's a real number. All right, some important facts. If n is even, then the square root, let's see, whoops, I forgot that was supposed to be there and there. Okay, the nth root of x exists only if x is positive or 0, because you can't multiply something by itself an even number of times and end up with a negative. So that's just like the negative 1. So if n is even, if that means our root right here, our nth root is an even number, x only exists if it's positive, right? Because if we have negative 2 times negative 2 times negative 2, right? So it'll be negative 2 to the third. We're not going to come up with a negative number, or we're going to come up with a negative number because two of these cancel each other. So we'd have 2 times 2 is 4, 4 times 2 is 8. It would be negative 8. So we can do a third root of negative 8. Now, if we do it to the fourth, right, so we say negative 2 to the fourth, negative 2 times negative 2 times negative 2 is negative 2. We have pairs that will cancel each other out anytime that is even, and we're going to come up with 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and it's positive. So we can have a fourth root of 16, but we cannot have a fourth root of negative 16, okay? Can't have that because when we multiply 2, 1, 2, 3, 4 times, it's not negative anymore. If n is even and x is positive, then the nth root of x is always positive. All right, so let's explore that one. N is even and x is positive, then it's always going to be positive. All right, so let's say that we had a fourth root, that's our n, of, let's say, 16, right? It's saying that if n is positive, that's a positive number, or an even number. If n is even, that's an even number, and x is positive, that's a positive number, then it's always going to have to be positive, even though there will be both positive and negative nth roots. Okay, so that means that if we had 2 times 2 times 2 times 2, right, it's going to have to be 2, okay, because that's positive, so our root is going to have to be positive. All right, if n is odd, then n to the x exists whether x is negative, positive, or negative. All right, so if that's odd, right, that means we can end up with a negative. If n is odd and x is negative, then the nth root of x is negative. If n is odd and x is positive, then the nth root of x is positive. Okay, so remember, when it's odd, like negative 1 times negative 1 times negative 1, right, we're going to end up with a negative. When it's even, we're going to end up with a positive. Okay. All right, let's look at some examples of these. Okay, the fourth root of negative 16 does not exist in the real number system because we can't say, let's see, 2 times 2 is 4, 4 times 2 is 8, it would be 2. But we can't say negative 2, negative 2, negative 2, negative 2, and come up with a positive number, right? Or a negative number. It's going to always come up with a positive number. Okay, so we're always going to get positive 16 when we multiply that negative 2 3 times, or 4 times, even number of times. So if this is even and this is odd, then it's not going to work. All right, let's try this one. So it says the eighth root of 256 is 2, not negative 2. Okay. And the third root of negative 125 would be negative 5 because third root, and that's negative. So this is odd, right? And that's negative. So we can end up with a negative number, right? So if we do negative 5 times negative 5 times negative 5, we're going to end up with negative 125. Now this is odd, but this is even right here. I mean positive right there. Whoops. Here, let me mark those. Odd. Our n and our x is positive. So this is going to be positive. Okay. Odd. This is even. So this is going to be positive. Okay, so if your exponent is even, then your x has to be positive. If your n is odd, and that's negative, then it's going to be negative. If it's odd and that's positive, then it'll be positive. Hopefully that makes sense. All right. For most numbers, the nth root is not an integer, but hang on one second. The nth root of x still exists. Okay, so for most numbers, and that's supposed to just be square root of 2. For most numbers, the nth root is not an integer, but the nth root of x still exists unless x is negative and n is even. For example, the square root of 2 is approximately equal to this big giant number right here, but the actual value would go out into an infinite number of decimal places. In fact, it's impossible to write the exact value of the square root of 2 as a fraction with an integer on top and an integer on the bottom. A number that cannot be expressed as such a fraction is called irrational. So irrational numbers cannot be written as a fraction. Okay, and that would be something like the square root of 2, okay, is an irrational number. Its decimal point just keeps going on and on and on forever that way, okay. Fractional exponents. In addition to using the radical sign, we can express nth roots with exponents. All right, and we did this before. So x to the 1 over n is the principal root of x, right? We can interpret any fractional exponent in the following way. X to the AB is the same thing as that. The easiest way to remember this is the square root of x is x to the 1/2. Okay, our 1 goes here and our 2 goes there. Whatever's on the bottom is going to go here. That's our root. And whatever's on the top is going to be the exponent. Okay. And now the way that they write it in this book, the exponent's not going there. It's going in parentheses here, right? Because if we multiplied this, it would be x to the 1/2. All right, let's try some of these. All right, so we have to find these. We've got 9 to the 3 over 2. So when I write that, remember, square root means x to the 1/2. See, did that wrong. All right, so x to the 1/2 is the square root, and it is 1 here, half there, right? Square root means the 2's up. The 2 is our root. Okay, so that means that our top number would go inside the box with the 9. That's going to be the exponent of the 9 is our top number, which is 3. And our bottom number is going to be there. So this means the square root of 9 to the 3rd. Right? So if I multiplied this out, the square root of 9 to the 3rd, 9 to the 3rd is 9 times 9 times 9. Which would be hang on, well, no. What we need to do, much easier than that. If we write it like that, what's the square root of 9 is 3, and so we need 3 to the 3rd. 3 times 3 is 9. 9 times 3 is 27. Okay, it would have worked the other way. I could have done 9 to the 3rd and then square rooted that, but it's a lot easier to square root first and then do your exponent. All right, let's do B. All right, so this one is -8 to the 2/3. Okay, so remember our top number is what we're going to multiply by. That's going to be our exponent. Okay, and then our bottom number is going to be our root. All right, so if we have -8 And our bottom number is our root. Okay, then our top number is our new exponent, which is squared. All right, the third root of negative 8 would be negative 2, because negative 2 times negative 2 times negative 2 is going to be negative. 2 times 2 is 4. 4 times 2 is 8. Okay. But we still have to square that. So 2 times 2 is 4, and that'd be negative 2 times negative 2 equals positive 4. So that one is positive 4. All right, and then this last one, C, 1,000 to the negative 2/3. All right, now remember about negative exponents, we have to drop that. So if we have 1,000 to the negative 2 over 3, we're going to have to drop that down below a 1 right there to the bottom of a fraction to get rid of that negative. So now we got 1,000 to the 2/3. All right, and then that means we can write that as 1,000, and then 2/3, remember our top number squared, and our bottom number goes there. Okay, so if I did 10 times 10 times 10, 10 times 10 is 100, 100 times 10 is 1,000. So that's going to be 1 over 10 squared, and then 10 squared is 100, so it's going to be 1 over 100. Okay. All right, I hope that made sense to everybody. That was just kind of a review lesson because we already did ones like that last year. All right, thanks for watching. That's it for that.